All right, guys, welcome to another video. Thank you for watching and supporting the channel. Today, we will be discussing what differential equations are. So this is a very introductory video of what differential equations are. If you are currently in the differential equations course in college, I don't think this would be much help in that regard other than just kind of give you an introduction. This is more geared towards someone that's either taking this in Calculus 2 or maybe in a high school Calculus BC idea. This is more of an introductory of the idea of what they are. Okay, so let's go ahead and get started. Number one is, what is a differential equation? So by definition, a differential equation is any equation that contains derivatives of any order. Okay, so what does that mean? Let me give you an example. So let me skip this paragraph here and go down here. Here's a differential equation. Differential equation has, in this case, y double prime minus y is equal to 0. Y is an equation. Number one, it has an equal sign. And number two, why is it a differential equation? It has a derivative. Remember how the definition says derivatives of any order? What that means, it could be the first derivative, the second derivative, the third derivative. That's what an order is, right? So the first derivative will be known as the first order, second derivative, the second order, and so on and so forth. Okay? So that's what a differential equation is. Now, typically, you're going to be asked to solve an equation, right? So if we go back to algebra, what does it mean to solve an equation? Well, to solve an equation is we take an algebraic expression, such as, like, I don't know, let's say 2x plus 1 is equal to 5, and your job would be to isolate x by moving the 1 over, dividing the 2, etc., right? So that'll be an example of solving an equation. That's what you are more comfortable with, I would assume, at this point. But what does it mean to solve a differential equation? Okay, so what it means to solve a differential equation is to undo the derivatives. Okay, so what helps you undo derivatives? Well, at this point in your course, you should already learn antiderivatives. Okay, now we will eventually talk about how to solve differential equations and, in this case, use antiderivatives. But before we get there, I kind of want to introduce you to what would it mean to be a solution. What is a solution to a differential equation? Okay, so let's look at another sentences that I have on the whiteboard. So it says, a function y is equal to f of x is a solution to a differential equation if the differential equation is satisfied when y, which is your solution, and its derivatives are substituted. So let me show you an example of what that means, okay? So again, this is not me showing you how to solve a differential equation, it's the opposite. I am going to provide you with a solution, and you're just gonna check if that solution is in fact a solution or not, okay? So let's look at it. So our differential equation from earlier said that if we have the second derivative and I subtracted y, which is my solution, I should get 0, okay? So to prove this, rather than using antiderivatives, I'm gonna use the opposite, which is use derivatives to help, okay? So here's what I'm claiming the solution is. I am claiming that the solution is sine of x. Okay, well, I'm gonna take the second derivative. Why the second derivative? Because it has a second derivative in the differential equation, okay? First derivative of sine is cosine. Second derivative of sine would be negative sine of x. Okay, so what do I have to do? At this point, I'm gonna take this information, I'm going to substitute it in here. I'm also going to take this information and I'm going to substitute it in here. If sine of x is a solution, that means that when I take my second derivative and I subtract my solution, I should get 0. So in this case, as you can see, if I take negative sine of x minus my solution, which was sine of x, the question is, do I get 0? Okay, so I like to put this little question mark because I'm not setting it equal to 0, and that's very important. We're not solving for 0. I'm not asking you to subtract these two signs and set it equal to 0. What I'm asking you to do is, does the left side equal to 0? So it's important to put the question mark, or at least I like to do that, okay? So at this point, you can obviously see that if I combine the two signs, I definitely don't equal to 0. Therefore, y is equal to sine of x is not a solution. Okay, so maybe not what you expected for your first video, right? So again, based on what I said earlier, the way to solve a differential equation would be to actually use anti-differentiation. I did not use that. So to begin with, and to get you kind of used to this idea of what solutions are, is we're gonna use derivatives. So I'd like for you to pause the video, take a shot at this. Try to see if this is a solution, okay? All right, I'm assuming you went ahead and did that, so let's go over it together. So in this case, same thing, I'm going to take two derivatives. Again, the only reason why I'm taking two derivatives is because the differential equation is of a second derivative, okay? All right, So first derivative will be 4e to the negative x, but because of the chain rule, I will need a negative in the front, so I'll be negative 4e to the negative x. Second derivative, again, would be negative 4e to the negative x, but again, I have a chain rule, but because of this negative, this would actually go back to positive, okay? So according to this, again, I need to take my second derivative, which is 4e to the negative x, and I need to subtract my supposedly solution, which is 4e to the negative x. Again, don't forget to put a question mark in here to see if it actually does equal to what it claims it equals. By the way, it doesn't always have to be 0. In this case, it just is, okay? So is 4e to the negative x minus 4e to the negative x equals 0? Yes, indeed, 0 is equal to 0. So therefore, y is equal to 4e to the negative x is a solution. Perfect. So I don't want to make this video super long because I think that with one example, you get the idea of what it is to determine if something is a solution. So rather than using what your intuition tells you, which you are right, to use antiderivatives, and just like we discussed earlier in the video, the way to solve a differential equation would be to use antiderivatives. First, I want to make sure that you practice by using derivatives, and I'm going to provide you, or your textbook's going to provide you, or your teacher's going to provide you with what a solution could be. And your job is simply to use derivatives to verify whether it is a solution or not. Okay? So, on my next video, I will then explain, well, how do you actually do this? So, I'm going to show you 3 different ways to approach how to solve a differential equation. One of those ways would be known as a slope field, which is a visual representation of a solution. The other one will be known as Euler's method, which is a numerical representation of a solution. And then lastly, I'm going to give you one of the techniques for you to actually do this analytically. And again, it's just one of the techniques because remember, this video is geared towards students not taking the actual differential equations course in college. This is more of a Cal 2, maybe high school calculus, introduction to differential equations. Anyways, thank you for watching. Let me know if you have any questions in the comments, and we'll see you next time. Take care.